sit back, kind of see what the whole objective is on all these problems. Yes, Connor?
I didn't get this worksheet.
That's fine, you can wait. Okay? You didn't get this worksheet?
Yes, you did.
Come up and get it.
Connor, we literally did the first problem.
Okay, so when looking at this problem, all these problems we're looking to see which one runs out. And you're always given two reactants. One's going to run out, one's going to be used up all the way. And we call the one that's used up all the way the limiting. How we can tell is the one that produces the least amount runs out. So does everybody see why O2 is limiting? Okay? Now you'll be given some really easy problems just like this that you just have to do, recognize you have to do two setups and come up with the answer. Okay? They get a little bit more complicated as we get down to 3 and 4, but
Well, 3 and 4 is not what
yeah. So I will show you 3. Okay, so a lot of you got this second one done because you wanted to practice on your own how to do it. And so if you did the second one, it's the same as the first one. It's just different numbers and different products you go to. Okay, I would suggest if you don't have it done, then you can copy this down and have it as a reference. Okay, because I know some of you going around, you only had one done, and you didn't do 2, 3, or 4. So at least you can copy this one down and have a reference of another example. Does anybody have questions on the answer for this one? Okay, same process, the one with the lower amount, if you do your mole ratio right, is your limiting. Correct? Okay, now, on this next slide, I just want you to look to the right. Okay, now if you didn't do it, you're going to be writing a lot. So I'm going to put this, I'll make a copy of this and put it on Google Classroom, and that way, when you have time to do it, then you can look off of Google Classroom and just see how it works. Okay? So on this one, just look at this to the right. Okay, that's all I want you to do is look to the right. Box on the left, don't worry about box on the right. Those who have completed that, does that look like your answers you came up with for your weights?
Yes. I
Okay.
had 25 point, or
No,
No, I didn't.
I missed a step. I missed both the last steps on those two.
Okay, where did you stop at then?
I stopped at 2/1 and 2/3.
oh wait,
Okay, now, here's the deal. You can stop there and still figure out your limiting.
never mind.
So, you stopped after you didn't go all the way to grams, right? That's okay, because you still can find the limiting, right? Because it'd be the least number of moles.
Yeah.
And so it'd still be SiO2, right?
Mhm.
Okay. Now, the thing is, maybe you don't want to stop. Now, when I showed you guys the problems, I stopped after moles. But on this one, what's it want to know? It wants to know how many grams. So then you just take it one step further. Okay?
How do we solve for the excess reactant?
Okay? Let's just do this one at a time. So we'll get to that here in a second. So then you just do mass to mass, and then once you get your grams, then you can kind of see which one is lower is your value. So the answer for how much this produces is 22.5 grams. It's this answer. Okay? Because that Si2 is all gone. It's 0. It's 0 when we produce 22.5 grams. So that means we cannot produce that extra amount between those two. We can't do it. Now, here's the question. We'll look at this work on the left. Okay, before we look at it, how do you decide, or what is used to make that decision of how much is left over? So which one of these two, SiO2 or C, is left over? Which one's left over? Okay, so C's left over. We know we have extra amount of it, and the question's asking, well, how much remains behind? And so then what you do is, what do you have to use in which to see how much of the carbon was actually used up? what would you do, what process, where would you start the process to determine how much of the actual carbon is used up? What would you,
Or you'd start with how much product you had, right?
we could go to our product and go backwards.
Yeah.
So we could take, and some students can do that. I'm not going to show it that. I don't want to show it too many different ways. But what Drew's saying is you could take the 22.5 grams of CO and go back to carbon, grams of carbon, and then that value is what's used up. So you can do it that way. Okay?
I'm confused what you're even asking.
Okay? So Raquel. So you're saying you don't understand what I'm asking. Okay. So remember with the blocks we did. Okay? So we went through and we formed a product.
Yes.
Did we have anything left over that we didn't use?
Yes.
That's what we're trying to find.
Okay. So why? Like, I'm confused with what you're saying with how Drew is.
Okay? So Drew's saying that this is all we can make. Right? That is it. So if this is all we can make, grams of CO, what he's saying is we can take this grams of CO and go to the original carbon, which is right here, and to figure out how much of that carbon was used to make that 22.8.
But why the original carbon?
Because that's in excess. We have leftover amount of carbon. Because when we use this, we realize that that wouldn't be all used up because the limiting is SiO2.
It's kind of mixed.
Okay? Now what I did, I took the SiO2 because I knew that that's going to run out, right? 24.1 grams of SiO2 is going to run out.
And
Now,
you did it-
Drew's method would work just as well as this one. So if he did it with the 22.5 and went to carbon, he'd get the same answer. Exact same answer. I'm starting with the grams of SiO2, and I'm figuring out how much of the carbon's used up. So that's this going grams of SiO2. I'm going to figure out how many grams are used up.
And how do you do that?
How do I do that?
Yeah.
I just do a mass of grams of SiO2 and find out how many grams of carbon I have. This, like the other two.
Hold on, I wonder why that is.
Okay? Now, that's how much is used up. How much do I have available of carbon to start with? I had what? 22.8. So what would I do to see how much is left over?
You need grams of carbon for what's left over?
Yep, I'd have to subtract them, right?
Is that 60.09?
This is what's used up. Okay, because is this all gone after that 14.5 grams of carbon is used up? Is this all gone? That's all gone. How much of the carbon used up is this amount? So I started out with 22.8. And so if 14.5 is actually used up and then the reaction stops, then I have 8.3 grams in excess. And that's the answer. Okay, that's the answer. Okay? So now you have an example. If you want to write that down, you can. I'm going to have you do 4 on your own, and then you can check your answers with me. Okay? So if you got individual questions at this time, you can ask those, because not everybody's going to get it right now. It's just the way it happens. Okay? Now, let's go to your lab and discuss your lab.